Welcome to The Explainer. Today, we're going to look under the hood at something we use every single second of every day: digital electronics. I mean, have you ever really stopped to think about how the screen you're looking at right now is even possible? Well, let's dive in and figure it out.
Just think about your daily life. You're surrounded by all this amazing stuff. High-definition video, music that sounds crystal clear, games that look more real than reality. We stream, we share, we create. It all feels so incredibly rich and, complex.
So, that's the big question, isn't it? How can a chunk of metal and silicon possibly get the nuance of a song or the emotion in a movie scene? How does it make any sense of our world?
Well, the answer lies in this kind of secret universal language that every single digital device speaks. And the really wild part? It's way, way simpler than you could ever imagine.
So here's the first big secret. Your computer doesn't understand a photo of a cat the way you do. It doesn't feel the beat of a song. It doesn't deal with concepts at all. All it processes are simple electrical signals. That's it.
See, the world we live in is analog. Think of a sound wave. It's smooth, it's continuous, it has infinite tiny variations. But a computer just can't handle infinity. It needs to simplify. It has to chop up that smooth wave into a bunch of separate, countable steps. It has to go digital. And this is how it does it, with binary code. It's a language that only has two symbols, 0 and 1. Now, why just two? It's all about reliability. It's so much easier for a circuit to know for sure if a voltage is high, which we'll call a 1, or if it's low, which we'll call a 0. Trying to reliably detect 10 different voltage levels? That's a recipe for disaster. So every single piece of digital information you've ever seen is just a really, really long string of these simple on and off states.
So to put this in perspective, think about how we count. We use 10 digits, 0 through 9. So the number 10 is, a 1 and a 0. Easy. But for a computer, which only has 2 digits to work with, that exact same value is represented as 1010. It's just a sequence of on-off signals.
Okay, so now we get how computers can represent information. But that's just storing stuff, right? How do we get from just holding numbers to actually doing something with them? How do computers think?
This is the really crucial step. It's one thing to store a bunch of ones and zeros. It's another thing entirely to get them to make a choice, to produce a result. How do you go from just having data to making a decision?
There's actually a really clear roadmap for how this all works. You start with the basics, the number systems, and then you start building up with these key components called logic gates, and then you combine those into combinational logic circuits. Each idea builds perfectly on the one before it, creating something incredibly powerful.
And the absolute key to all of it, the fundamental building block, is something called a logic gate.
This little diagram here, that represents one of them. I know, it might not look like much, but this little guy right here is basically the heart of every single decision your computer ever makes.
The best way to think of a logic gate is like a tiny, microscopic bouncer at a club. It gets some inputs, some ones and zeros, and it checks them against a really simple rule, like are both input A and input B turned on? And based on that rule, it produces one single output. A 1 for yes, the rule is met, or a 0 for no, it's not.
So how do we get from that one tiny little decision to the powerful machines that we're using right now? Well, we start stacking these digital bricks.
It all works in layers. At the very bottom, you have the single bit, a 1 or a 0. Then you have logic gates that process those bits. You combine a handful of gates, and suddenly you have a circuit that can do a specific job, like adding two numbers together. Then you take billions of those circuits, put them all together, and bam, you have a modern processor.
So every single time you tap your screen, or swipe, or click your mouse, what you're really doing is setting off this massive, cascading chain reaction of billions of these super simple yes or no decisions happening inside the circuits.
But here's the real magic. It's the speed. These little on-off decisions, they don't happen once or twice. Oh no, they happen billions of times, every single second. It's that unbelievable speed that turns very simple logic into incredibly complex results.
And that brings us right back to where we started. The entire foundation of our modern world, everything from your phone to the global financial system, is built on this one beautifully simple idea.
Remember that stunning, rich digital world we talked about? All those videos, all that music, those incredible games. It all just boils down to these three things: A simple language with only 2 letters, a set of simple yes or no rules, and the power to do it all at an absolutely mind-boggling speed.
It's really kind of poetic, right? From just 2 simple numbers, from on and off, we have built a world of seemingly infinite complexity.
The simplicity is what makes it so genius, and it really just leaves you with one final thought. If we've already built all of this with just a 1 and a 0, what on earth are we going to build next?